So intro to physics with some frequently asked questions. So here's a whole bunch of questions that get asked over and over again for HSC Physics. So let's see if we can try and answer them. Question 1, how well does physics scale? Firstly, don't worry about scaling because what you want to do is focus on doing your best for each subject, and this is true for all your subjects. So just because so physics does scale quite well, but just because a subject is said to not scale that well, don't go ahead and neglect it, or don't go ahead and drop it just because of scaling. If you enjoy the subject, keep it, do it, and just genuinely enjoy the subject. But yeah, physics does scale pretty well. Do you need to know prelim content in year 12? The answer is yes, but you won't be directly assessed on it, so there probably won't be full questions dedicated to it. It's just stuff that you will need to understand in order to understand the year 12 content, because much of the year 12 content either uses or builds upon the year 11 content. So yeah, year 11, a lot of it's quite fundamental stuff, like when you're talking about forces and things, you'll be talking forces in general, and then maybe in year 12 you'll be looking at specific, force on a charged particle in a magnetic field or something like that. So yeah, having an understanding of the year 11 stuff is quite important. So some knowledge is used more than the rest, and these modules are what has been picked because they're the most used in year 12. But not saying that modules 3 and 4 aren't used, because they also turn up in year 11, 12. And another question that gets asked quite commonly is, how many hours a week should I study for physics? Well, that totally depends on you. Study until you get it, right? So Haranish has recommended 30 minutes to 1 hour. That's what he did to understand what was happening. But study until you get it is a pretty good way to sum it up. Like, I wouldn't recommend stressing about something until you're wasting your entire time on it. But if you don't understand something, go to your teacher during your spare time. Ask a friend. Ask a tutor if you guys are doing tutoring and that sort of thing. But don't waste all your time stressing about one specific subject or one specific topic within a subject, so that you completely ignore everything else. But yeah, definitely make sure you get each thing as you go, rather than waiting till the end and then reviewing everything and stressing out about the fact that you didn't understand certain bits and pieces here and there. So on top of this, allow time to finish homework, do your assignments and practice applying your knowledge, and make sure you're balancing your time across your subjects and consider what you're best and worst at as well. So yeah. Another question is, should you drop physics in year 12 if the mark is XYZ? Well, the answer is no. If you you should drop a subject because you aren't enjoying it, or because you don't have time for it, or if you're picking up another unit of math or something and you don't have, and you feel like you're spread too thinly across all these things, then maybe drop a subject. But just because you have your mark's not that great in year 11, don't drop the subject. Just I would definitely recommend keeping the subject, working on it, because many students tend to see, just like Haranish had seen here, and it happened for me as well, marks jumped as I went into year 12, just because firstly there's a lot more content, resources and things that I found were a bit more available in year 12, and in addition to that, people sort of put in more time and effort in year 12 compared to year 11. So yeah, just because your mark's not that great in year 11 doesn't mean you have to drop the topic. Sorry, drop the subject. Yeah, so how should you handle the new syllabus? That's another question that gets asked. Now, it's not that terrible anymore because you guys are the 6th group to do the new syllabus. So there are now plenty of resources available. But even if, for example, for maths, you guys, I believe, are the 4th cohort to do the new maths syllabus, or 4th or 5th cohort to do the HSC for the new syllabus. Even then, you guys have a fairly good set of resources available. But even if they introduced the new syllabus last year, you guys still would have your textbook. You guys still would have a whole bunch of resources, even from the past, which are still relevant. And I'm saying that because you don't have to completely rely on if it's 2020 when the new syllabus came out, you don't have to rely on everything past 2020 only. You can still rely on everything before 2020, but maybe there's a few topics that aren't in them, and there's a few topics that are in them. So pick out the relevant ones and still use them. They're still perfectly fine. So yeah, just be careful that the resources that you're using are designed specifically for the new syllabus. There is plenty of resources, plenty of online. So again, definitely 8 Notes has all their resources online through their website. There's also plenty of textbooks available, right, which have a whole bunch of great practice questions. So yeah, use them. and many teachers also tend to give out their own resources. So yeah, definitely use those as well. In terms of how you should make notes for physics, notes are passive study. The primary purpose should make active studying easier. But when I'm saying this, I also want to say that different people have different styles of study. But when it comes to STEM subjects, quite often, especially for physics and math, you want to try and do as many practice questions as you can, because you're using the theory in order to solve practice questions. But in addition to that, if you go to the HSC past papers, you'll be able to see quite dense questions involving a whole bunch of writing, and a lot of it is content based. So notes, I would say, are quite helpful there, especially for module 7 and 8, where you're talking about like the history of physics sort of thing, or like different experiments which are less so quantitative but more so sort of a description of what's going on, what happened, and that sort of thing, and the developments that came along over time. That's not something you write out a formula and sub in the numbers or something. It's definitely a content based thing. So yeah, notes, I would say, are quite useful, but make sure that you're also doing questions as well, solving specific questions, answering different questions. So when I say solving questions, some people may limit that to quantitative questions. So they definitely do quantitative questions, but in addition to that, also do questions where you're asked like long responses, or maybe 3 markers, 4 markers, where even a short response sort of thing where you're writing down things. So in another question that gets asked is, do you need to understand the practical experiments / know practical skills? The answer to that is yes, because exams can and will ask about them. Some schools even tend to do exams which use them, right? You have exams which you're doing an investigation on the spot. Like for chemistry, maybe you do, I'm not sure if distillation is, sorry, not in chemistry you might do something like dilutions, for example. In physics you might do something like the pendulum is a very common one, where you're doing it in an actual timed exam situation, and you'll be taking the results and doing the questions. Now they won't be too crazy about the results being super accurate, but what they will be interested in is your is your experimental technique, your understanding of experimental theory, and all that sort of stuff. So yeah, practice graphing skills. So even if you're not actually doing the experiment in the exam, maybe they'll give you, even if you're not doing the experiment during the exam, maybe they'll give you a whole bunch of data that you need to graph and then draw conclusions from. So practice your graphing skills, understand what are the key parts of a graph that need to be there in order for that graph to make sense. Also be able to discuss experiments. These are keywords: reliability, accuracy, and validity. Those 3 are very important words, and you need to be able to understand what each of those means and understand what you need to do to increase reliability, to increase accuracy, to increase validity. Or whenever you're designing an experimental setup, especially for depth studies and that sort of thing, make sure that you account for reliability, make sure that you account for accuracy, make sure you account for validity. You also need to be able to identify sources of error, to figure out, why is this not accurate? So if I've gotten G as being, 6.5 meters per second squared, whereas the real value is 9.8, why is this off by this proportion? Well, that's probably because of air resistance, maybe, or maybe because of some other friction or some resistive force on the setup. All these other factors, or some sort of experimental error, all these things. So identify sources of error, and then suggest improvements to improve experimental design. So another question that gets asked is, how good at maths does a person need to be for physics? Well, the answer to that is, it depends on how you feel. So about half of HSC physics directly involves maths, and even more involves quantitative skills, so interpreting graphs, trends, etc. But the main thing to see here is that there's not much hard maths, as you can say, if you call it that. It's more based on your comfort level. So in terms of hard maths, they're not going to expect you to be able to use calculus to solve questions. It's all going to be algebra based, although calculus in some parts can improve your understanding of the question, or improve your understanding of the content, but they're not going to require you to understand calculus in order to do questions. The hardest math you're going to do is probably, if you call it hard, it's going to be like quadratic equations, maybe some algebra, maybe some trig. But there's also ways around, avoiding topics that are more complicated. So rather than having to use the quadratic formula. For certain questions, there are ways to split the question up in order to use just algebraic manipulation, or in opposition to using the sine rule and the cosine rule or something like that. There are ways to just rely on just 90-degree right angle trigonometry. So yeah, don't worry too much about that. I would recommend doing advanced maths at least. However, you can do fine in standards so long as you practice. The key thing here is practice. Just like in maths, physics also uses a lot of maths concepts, so make sure you're familiar with them. But yeah, advanced math is what I would recommend as well. So what's your biggest tip for physics success? The answer is practice. So like I said earlier, physics is a subject based on solving problems. So the best way to get better at it is to practice. So try questions, so textbook questions, topic tests, practice papers. All these resources are available for you guys. So just do them, use them, understand where are your strengths, where are your weaknesses, see how you apply the content, and that's a very big part of these things. Okay, so it's now into some module 1.